Number 1 says use your reaction from pre-lab A to calculate delta H total. So in adding that up, we got our reaction for the total delta H to be delta H for the first reaction minus delta H for the second plus delta H for the third. I'm going to plug in some random values. One group got negative 427.2 minus, they actually got a negative 160.25 plus 285. They ended up with a negative 551.9 kilojoules per mole. Again, your number might be different than theirs. Number 2, it says, is this reaction exothermic or endothermic? Very simple. This reaction is going to be exo. The answer they want, delta H is less than 0. This is releasing heat. It's a combustion reaction. Moving on to number 3. It says, is the entropy. Now remember, whenever they use this word entropy, they're talking about disorder. And we've been talking about that as messy. And the symbol they're looking for is delta S. Okay, it says, is the entropy change for this reaction positive or negative? Delta S is going to be greater than 0 or positive because more moles. Actually, excuse me, I apologize. It's going to be less than 0. It's going to be negative because less moles are produced. Let's go ahead and look at that reaction. You know, it's Mg plus 1/2 O2, formation of magnesium oxide. We got 1 mole on the reactant side. We got 3/2 moles on the reactant side, 1 mole on the product side. It's getting cleaner. Problem 4 says use the major thermodynamic equation. We know that is delta G equals delta H minus T delta S. God, I hate this stuff. All right, to explain the conditions when the reaction is spontaneous and the conditions when the reaction is non-spontaneous. All right, spontaneity, we're talking about delta G. So delta H is negative minus T times A negative delta S. Make this a positive and make this a positive. All right. So at low temperatures, delta G could be less than 0. At high temp, delta G is greater than 0. When delta G is less than 0, we're talking about a spontaneous reaction. And when delta G is greater than 0, we're talking about a non-spontaneous reaction. Okay. To review this really quickly, when temperature is really low or even at 0, that's going to cancel out and the negative side is going to win. When temperature is really high, the positive side has a greater chance of winning. And a positive win equals a non-spontaneous reaction. Moving on to 5, this is a standard Hess's law. No bond enthalpy values are shown. We see no formation values, so we are going to add up the steps of this reaction. Let's go through each one by one. I forgot the coefficient of 2 here. In the overall reaction, okay, O2 is seen here, and O2 is seen in the overall reaction. The only difference is this number here needs to be multiplied by 2 to take care of the 2 in the coefficient, and this sign needs to be changed to get the O2 over to the reactant side where it's seen in the overall reaction. All right, that's done. We're good there. In the next reaction, H2O is seen as a product in the subreaction, and it's actually seen as a product in the overall reaction. Coefficients are 1 in both cases, so we are fine here. No problem. That value is good. Going on to the next one. Carbon dioxide is seen as a product in the subreaction. It's seen as a product in the overall reaction. Coefficients are 1. This value can stay the same as well. We're good there. Moving on here. Methane, CH4, is seen as a reactant here. You know it's seen as a product there. It's seen as a reactant here. Coefficients are the same, but we're going to have to flip the sign. Okay. We're good there. Now this next one is really, really tricky. Hydrogen gas is seen here. You notice it's not seen in the overall reaction anywhere. So what we're going to do is we're going to look for another reaction where it's seen. It's seen in the one above it. There it is. Because we had to flip the sign on this, it's actually seen as a product. Well, we want it to cancel, so we're going to switch it to a reactant on this side, and we're actually going to multiply it by 2. So we're going to flip this sign to 436, and we are going to multiply it by 2. To get an overall delta H to be 2 times 249 plus a negative 803 plus a negative 643 plus 75 plus 2 times 436 to give us an overall delta H of negative 2552 kilojoules per mole. Let me know in class if you have any questions with this portion of it specifically. Moving on to 6, it's kind of a tricky question. It says, which of the following is true when ice melts? All right, so we got H2O solid going to H2O liquid. Let's look at this problem quickly. All right, they are talking about this thing delta H. They're talking about delta S, and they're throwing this weird thing in here, delta V, and they tell us that that is volume. All right, so let's analyze each one individually. Ice melts. It has to absorb heat. Heat has to go in for it to melt. That's going to be a positive delta H. Delta S. A solid form, the ice cube, is much more ordered than the liquid form, a little puddle. So it's getting messier. That's going to be a positive delta S. The fact that we have 2 positives rules out A, it rules out C, and it rules out D. So we either got B or E as our options. Now that makes this either a plus or a minus. Volume change. What happens when water melts? Our normal logic would be to say that the volume increases. And that's actually not true in this case. When water melts, its volume actually decreases, and this has to do with something called thermal expansion. Density is defined as mass over volume. We know that an ice cube will actually float on its liquid form. Okay, this is the solid, and this is the liquid. What that means is the solid form is less dense than the liquid form. It is less dense than the liquid form. If the solid form is less dense than the liquid form, for the same mass, it would have a greater volume. Therefore, when it melts, the volume actually decreases. The liquid form takes up less space. It's more tightly packed. The solid form takes up more space, giving a positive delta H, a positive delta S, and a negative value here. The answer is going to be E.